Good morning, everyone. My name is Islam, and today I'll be presenting my project on factors influencing oil production. My research question is, what are the operational and environmental factors driving oil production? I believe large oil companies already use some kind of data analysis to improve efficiency, so I wanted to build a simple regression model that highlights which features are most useful for optimizing production. The dataset I used comes from Equinor, which is a large Norway oil company. The data was collected between 2008 and 2016 from 7 wells, and I downloaded it from their official website. It includes 15,000 rows and 24 columns. Overall, the dataset was very clean and complete. As for key variables, the recorded production date, name of the well, how many hours per day they worked, and also the recorded pressure and temperature for all the parts that I visualized here, like the surface, bottom, tubing, which is the pipe, annulus, and the choke, which works like a faucet controlling flow. Finally, the output shows oil with gas and water as byproducts. As part of EDA, I plotted production trend for each of the 7 wells. And here is the blue line, the amount of oil produced over time. The yellow is water production, and the red shows operational hours. From these plots, I see that 2 wells at the bottom didn't produce any oil, which suggests that they were only used for injecting water. The remaining 4 wells show varying production volumes. I chose well number 5351 for further analysis. For trends in production over the year, I see the seasonal pattern, with October consistently showing higher production compared to other months. Here I visualize scatter plots between key variables and oil production volume. One interesting observation is the strong positive correlation between stream hours and oil volume. It makes sense because more operational time directly contributes to higher production. For feature selection, I focused on variables with strongest correlation to oil production. The key features selected include wellhead pressure, choke pressure difference, annulus pressure, and tubing pressure difference. Additionally, there's some multicollinearity between downhole pressure and temperature, as well as tubing and choke pressure differences, so I excluded those 2. My initial modeling approach used multiple linear regression, focusing on the 4 key features I identified earlier. It already performed well, however, the residual plots revealed some minor deviations. To improve the initial model, I applied forward selection with cross-validation. The new feature set selected the final predictors, and the refined model achieved the testing R-squared of 82%, a significant improvement over the initial model. Residual analysis showed a more even distribution with fewer deviations. As for key assumptions, normality holds well, while there is no pattern in residual plots, and residual variance was mostly consistent. So we can confirm independence, homoscedasticity, and linearity. In conclusion, my analysis identified that you need to maintain pressure at the surface, temperature at the bottom, and pressure inside the tubing pipe, as well as keep high stream hours to improve oil production. The refined model performed well, explaining 82% of the variance in oil production. However, there is room for future exploration, such as nonlinear relationships or expanding the analysis to other wells for broader insights. So, thank you so much and have a good day.